Hi everyone, welcome to my channel Total Concise Understanding for Olympus NG. We have brought today a question from we can call it from a game theory or something like that, a grid type problem. Let's see what the problem says. We have a n cross n grid of empty squares. You can place a cross in all the square at one time, in all the squares one at a time. When you place a cross in an empty square, you receive I plus j points. If there are I crosses in the same row and j crosses in the same column before you place the new cross, which is the total possible score you can get? I'm written here is means there is only one possible score you can get. We have to find the score for a general value of n. So in the actual question, these are the which were the possible total scores, but since we are getting only one score, so I have modified the question to is because the only one score is possible in this game in all cases. So first of all, let's play the game once. I am drawing a 3 cross 3 grid. I'm just randomly putting the crosses just in order to show how it works. So here, here, here. In all cases, this is 0 plus 0. Here we don't have anything, so 0. Here we don't have anything, so 0, 0, 0, 0, 0. Now I'm putting randomly here. So we had, okay, I'm putting it here. So we have one cross already in the row and one in the column. So we have 2 points here. So cross. Now I'm putting it here. So we have 2 in the row and 1 in the column. So 3. So now I'm putting it here. 1 in the row, 1 in the column. Again 2. Putting it here. 2 in the row, 2 in the column, 2 in the row. So 4. Done. Now putting it here. 2 in the column, 1 in the row. So 3. Now here 2 in the column, 2 in the row. 4. Let's add it. 5, 6, 11 and 7, 18. This is our result. Now let's do it the same once another time. Just let's say let's take a 4 cross 4 grid now. In case of a 4 cross 4 grid, let's see what happens. Just putting randomly here 0, 1, 0, 2. I'm not explaining right now because I've explained the previous one. I'm just putting it 1, 4, 1, 2, 3, 3, 4, 2, 5, 5, 6, 6 and 6. So what is coming? 3, 7, 3, 7, 8, 9, 11, 14, 18, 20, 30, 48. Fine. So we are getting 48 in a 4 cross 4 grid. So now I hope you can understand the question is just saying to find out the same thing for general value of n. We have to use permutation combination here to solve this question. Um, so let's start with the solution. Let's see how to solve this question. First of all, I'm just defining a few terms, means row points, column points. These are the two terms, means we are just adding the row points and column points to get this. So these are the facts. So I hope you can understand the definition, means the points we are getting from the previously contained rows. This is the row points, and the points we are getting from the previously contained columns are column points. So these are the definition I am using. and we have to show that this is constant. The sum of row points and column points is constant for all cases for a given value of n. Right? Now let's draw n cross n grid. This is n cross n. How can I generalize it? Let's say we have this. We have this. Fine. Let's say this is an n cross n grid. Now what we can see is, let's see the concept behind it first. First of all, we are just claiming one thing. Row claim one. Claim, I'm writing it here, I think. Claim one. Row point equals to column point. How? Means this is just simple. We can just rotate the same thing about the center, and we can see the symmetry is there, so row can be interconverted into columns, and because of the symmetry we can say that row points and column points, the sum will have sum sigma row points sigma column points will be same, irrespective of anything. Means the order may change anyhow, but the sum will always remain constant by symmetry. So now we have to claim the second claim, which is our proof actually. Row point is constant for given n, and we have to find the value. I'm finding the value, so let's start. What we have seen in the previous two examples is that whenever I put a cross here anywhere, we know there is always a cross in the uh, in a row. In every row, let's say I'm again drawing a 3 cross 3 grid or 4 cross 4 grid just for example. I'm putting a cross here. Let's say this is the first cross in the row. And similarly, there will be 4 such crosses which will be their respective first crosses in their respective rows. So in that cases, the thing will be in that cases the points will be 0. So we have n cases where we have 0 points. Fine. And similarly, n cases where we have 0 points for both rows and columns. Now, similarly, we have n cases where we have 1 point. N cases where we have 1 point. Because in the same way, when there will be in every row, there will be one such case where there is only one cross there and we are adding another one. In some point of the game, not consecutively, not some. In some point of the game, there will always arise a situation where all the n rows will means all the for all the n rows we have 1 point each. I hope you can understand. Means I'm just saying we have here, here, here. These are the 0 pointed squares. Now we have to put some time. Here one square among these three. We have to put some among these three. So I'm just taking one of the cases here where we are taking n point. I'm taking here and I'm getting 1 point here. Row point. Column point I'm not interested here. Now here I'm getting 1 row point. Here I'm getting 1 row point. Here I'm getting 1 row point. So we are getting 4 row points here in this case 4 into 1. So I am here getting n into 1. Similarly, we will get n into 2, n into 3, and so on up till n minus 1 into 3. This is the maximum n sorry, what I am writing, n to n minus 1. This is the maximum possible case because we can't get n points in n cross n board. Row points. N row points in n cross n board because maximum number of square crosses present in a row is n minus 1. And here also n to n minus 1. So we are just adding this sigma n into r, that is r varies from 0 to n minus 1. So n sigma r equals to 0 to n minus 1 r. So this is equals to n into n minus 1 into n by 2 equals to n square into n minus 1 by 2. So this is our claim, that is n square into n minus 1 by 2. Row point is constant. So total points equals to 2 into row point. Since row points and column points are same, equals to n square n minus 1. And this is our answer. Now just let's verify this with 3 and 4 as we have done it. Putting n equals to 3, we are getting 9 into 2 equals to 18. Verified. Putting n equals to 4, we are getting 16 into 3 equals to 48. Verified. See, these are the only points we are getting here as well. This was entirely random event and we have got this 18 and 48. And we have proved that for any general value of n, we will get n square times n minus 1. So with this, we have come to an end of this video. Thank you so much for watching the video till the end.